So we're going to rewrite each of these in simplest radical form. Now that involves adding, multiplying, and subtracting and dividing. When you add radicals, you can think of them as variables in a sense. Here, radical 11, whatever it is, I'm going to think of it as x. And 7 times radical 11, I think of it as 7x. Radical 44, we can simplify. I think of it as 4 times 11. And 4 is a perfect square. So what we can do here, I'll break this down over here. It's equal to radical 4 times 11. That's 44. Square root of 4 is 2, so it's 2 radical 11. What does that mean? Well, that means here we can think of this as 2x. Now we just have a simple algebra problem to simplify. So what does this equal? X minus 7x is negative 6x plus 2x, just like negative 6 plus 2 is negative 4x. Plug the radical 11 back in, we have negative 4 radical 11. Part B, same idea, but now you might see that we can think of radical 2 as x. So we have x times 3x minus, let's rewrite this in terms of radical 2. Square root of 8 is 4 times 2, or 8, excuse me, is 4 times 2. And radical 4 is 2, so it's 2 radical 2. Just took the square root of 4 there, get 2. So now we have minus 2 radical 2, or minus 2x. So now we just distribute x times 3x, that's 3 times x, or x squared, minus 2 times x, or x squared. Now we plug back the radical back in, we get 3 times radical 2 squared, we're just squaring the radical, not the 3 as well, minus 2 times radical 2 squared. Same thing, we're not squaring the 2. The exponent is just sticking to the variable. When you square a radical, you undo it. They're inverse operations. So really, this is 3 times 2 minus 2 times 2. So that's 6 minus 4, which is 2. That's our answer. Part C goes back to this idea that you can just think of it as the radical 6 times 15. So you're multiplying, just multiply those two. And what's that? Well, it's radical 90. Now I break this down into factors. We get 9 times 10. 10 can't be broken down any further into any perfect squares. Sorry, I'm going fast here. This should be practice for you at this point. Take the square root of each of these. Well, square root of 10 we can't really touch. Doesn't have any perfect squares, can't be broken down. Square root of 9 is 3. We're done. D is nice because you're dividing, and in this case 12 and 4 are divisible evenly. So 12 divided by 4 is just 3. And we can rewrite this really quickly as 3 radical 54 over radical 3. So we don't want to leave the radical 3 in the denominator. We'll get rid of that soon, but let's just check if we can break down 54 any further. So 54, I know, by the way, is 2 times 27. And 27 is 9 times 3, right? So what does this mean? Well, we can't get rid of this 2 or 3, but we can take the square root of 9. So I'm just going to rewrite square root of 54. So we get 3 times, well, the square root of 54, take the square root of 9, that's 3. The 2 and the 3 are still stuck in there. That's 2 times 3 or 6. So I just rewrote that square root of 54. And that's over radical 3. Almost done. So now we have 3 times 3, which is 9, radical 6, over radical 3. So what do we do? Well, the question is, can you divide radicals like you multiply them? Let's try it. For something simple, radical 36 over radical 9. So if we use PEMDAS, we get square root of 36 is 6, square root of 9 is 3, answer is 2. But suppose that we divided 36 by 9 first. So that equals what? 36 divided by 9 is the square root of 4 then. And the square root of 4 is 2. So that works nicely. The square root of 6 over the square root of 3 is just the square root of 2. And we get 9 radical 2. And that's our answer. Okay, here's a problem that seems especially nasty, but as we break these things down, as we break each radical down, we realize it's not so bad after all. Now if we break down radical 120, right, the prime factorization, we're like, okay, that's 60 times 2. 2 is prime. 60 is 12 times 5. 5 is prime. And 12 is 4 times 3, right? Now 4 is a perfect square, so I'll leave it there. There are no other perfect squares in 120, but this basically means now that 120 is 4 times 2 times 3 times 5. Square root of 4 is 2, and we get 2 times the square root of, well, 2 times 3 is 6 times 5, right? That's 30. So now we have this instead of radical 120, which will work out nicely in a moment. Now radical 40, of course, break that one down next. Radical 40, just think of that as 4 times 10, right? And radical 4 is equal to 2, so we have 2 radical 10. Now radical 10 up here, we're not going to touch. We're just going to rewrite this. So we have 9 times radical 40, which is really 2 radical 10, plus 6 radical 10 over 2 radical 30. So what happens now? Well, here this is really 18 radical 10, and this is 6 radical 10. Altogether that's 24 radical 10, just like we add in algebra, over 2 radical 30. 24 over 2 is 12. And now we have 12 radical 10 over radical 30. Usually at this point you want to rationalize your denominator. So you multiply numerator and denominator by radical 30. Right? And what happens now is kind of nice. In the denominator, radical 30 times radical 30, what's that? Well, that's just 30. Right? If you square the square root. And now we get 12 times radical 300. Right? 10 times 30 is 300. And now we can break down radical 300. And that's 100 times 3. And take the square root of 100. That's just 10. So that's 10 radical 3. And this looks really nice now, I think, because we get 12 times 10 radical 3 over 30. And we can simplify this, right? We have 120. It's 12 times 10 over 30 times radical 3. And that equals 4 radical 3. So all that can be broken down into a nice, simple expression. All right, thanks.